This section is really short with some easy concepts, but then there's some challenging problems, okay? So it shouldn't take us too long to go through the lesson, and hopefully you'll have some time to start working on the homework. But there are some harder application problems that we'll look at. So all this is just an application to what we've been doing. We have been talking about right triangles, solving for angles, solving for sides. So why would we even need to do that in real life? Because you might have situations that create what are called angles of elevation or angles of depression. So when you think of an elevator, elevating something, what do you think of? Going up, right? If you think of depression, what do you think of? Down. So that's the big idea that you need to keep in your mind when you're thinking of an angle of elevation versus an angle of depression. Those last two vocab words here are going to be in reference to your horizontal line. So from a horizontal, and I can't stress that part enough because that's where everyone makes their mistake. You have to go from the horizontal, not from the vertical. From the horizontal, if you are going up, then you have an angle of elevation. So if I go up from the horizontal, I'm creating an angle of elevation. If I go down from the horizontal, I'm creating an angle of depression. Okay, but always from the horizontal. So from the horizontal up is elevating, from the horizontal down is depression. So if you look at this picture, this is the horizontal, so angle 1 is formed by going up from the horizontal, so it's an angle of elevation. This is also a horizontal, so angle 2 is formed by going down from the horizontal, so it's an angle of depression. Does that make sense? Okay, what's going to be true about every angle of elevation and every angle of depression in a picture like this? Okay, I'm hearing a couple of different things. What kind of interior angles? Yes. So because these are horizontal lines, they're going to be parallel to each other. And that means you have a transversal, and those are alternate interior. So therefore, every angle of elevation will be congruent to its corresponding angle of depression. Okay? So if a word problem gives you the angle of depression, but what you really needed in your picture was the angle of elevation, you can just say they're the same, and you can just put that angle measure in. Okay? Every time. All right, so they're going to start off super simple with these vocabulary words. Angle of elevation, again, is going from the horizontal to a point above the line, and angles of depression go from the horizontal to a point below the line. Okay? And we just said this, those are alternate interior, so they're congruent. So now the next few slides are just going to ask you what kind of angles are they. So go ahead and try. There should be maybe 4 examples. I'm going to cheat off Ridley's here. 3 slides, but 4 questions. Go ahead and try and see if you can answer what kind of angle is it. Angle of elevation or angle of depression? Do the next 3 slides. 1 on the front, 2 on the back. The next slide. You bet. Sorry. Sorry. Can you see it up there better? Yeah, it's too not a good picture. Sorry about that. Yes, you can. Okay, we'll start with this slide and we'll go backwards, okay? So let's start with the one that was 5 and 6. Hard to see on your paper. Look up here. So what is angle 5? Depression. We're going down from the horizontal. Again, make sure you are putting, I'm glad that, I think it was it Javi or Edwin who asked me? Javi. Make sure that you do put angle of. Don't just put depression or elevation. It's an angle of depression. But you can use that angle symbol And then 6, what is 6 going to be? Elevation, so angle of elevation. And what do we know about 5 and 6? They're alternate interior, not corresponding, but alternate interior, and they are congruent. Okay? All right, number 4. Going backwards, what is this? Elevation, angle of elevation. And then the first one that you did, angle 1, angle of depression. Questions before we start working problems? Everybody's good? Okay, again, the kicker is don't try to draw the angle from the vertical. I can't stress enough how many people, when we get to the problems, try to put this angle right here as an angle of elevation or depression. It can't go from the vertical. So every single time, if the word problem says you have an angle of elevation or angle of depression, ask yourself, where's my horizontal? And then the angle formed from the horizontal then is going to be that angle. Okay, never from the vertical. This is not an angle of depression or elevation. Okay, so then they're going to give you some problems where you have to read through it and create your own picture sometimes, and sometimes they'll give you a picture. Did I give you a picture on this one? Okay, so pretend you don't see this, because that's going to be the hardest part, coming up with the correct picture. So it says the Seattle Space Needle casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? Round to the nearest meter. So first of all, where are shadows? On the ground, okay? So that means we have our shadow here, which is 67 meters. The angle of elevation, so it's going from that horizontal, what direction? Up. So my angle of elevation is 70 degrees. And then if I did that correctly, I'd keep it going and then use my vertical line to create my right triangle. Okay, and we're trying to find the height of the Space Needle. So where's the height going to be? Or how do we measure height? Before we start solving, where in my picture is the height? The right angle is an angle. Where is height? The vertical line, okay? When you measure height, you're always measuring it straight up and down. Never should it be the diagonal side, okay? So be really careful with that. So we're looking for this side. So we're using which trig function? Tan, because this is what? Opposite and adjacent. Good. So now we're ready to just do what we've been doing. The only new thing today is just being able to create a picture using those words, angle of elevation or angle of depression. So we have tangent of 70 degrees is equal to what over what? Okay, and when x is up high, we multiply. So x is equal to 67 times the tangent of 70. Nearest meter, yes sir. 184? All right, 184 meters. Pretty easy? Okay, try the next one on your own. It's hard to get into a habit, isn't it? Yes. Let's see how we're doing. So first of all, it's talking about altitude. Be careful you don't confuse that altitude. It is the same altitude, but the directions do not say an altitude drawn from a right angle in a right triangle. That's different. That would be what we did earlier, section 8.1, right? This is just talking about the altitude of an airplane. And what does altitude mean? The height. So we've got a plane here in the air, and its altitude, which is its height, is 3,500 feet from the ground. Does that make sense? Okay. Then you have an angle of elevation. And again, I want to warn you because I saw a couple of you doing it. Angles of elevation have to start from the horizontal, not from the vertical. So then you need a horizontal line, and then you need to create an angle that is going from that horizontal up for it to be an angle of elevation. And that is 29 degrees. And then it says, what's the horizontal distance? So that's not going to be the hypotenuse here. That's going to be the other leg, right? And so what trig function did we use here? Tangent again. So tan of 29 degrees equals 3,500 over x. And when x is down below, you switch, you know? So x is equal to 3,500 over the tangent of 29, which is approximately to the nearest foot, 6,314 feet. Questions? All right, try the next one. This one's a little tougher, but not as tough as the ones coming. I'm letting you try it on your own right now. See how you do. Again, I saw about half of you with the right answers and the other half are still working, so we'll go ahead and just kind of clarify. This one to me was a little bit kind of wordy and trying to understand what is a crevice and what's the picture going to look like. And a lot of you may have drawn it differently than I draw it, but it may be the same. So an ice climber stands at the edge of a crevice that is 115 feet wide. So there is a crevice in the ground that is 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side. So let's say she's standing right here. She's up here. Thank you. I'm such an artist. The angle of depression from where she stands to the opposite side. So the angle of depression right here is 52 degrees. And again, you may not have drawn it the same way as me, so I can let somebody else share what they did if it helps. Okay? But if my angle of depression is 52 degrees, what else is 52 degrees? My angle of elevation, which means this is 52 degrees. Okay? So it says, how deep is the crevice? Do you measure depth diagonally? No. Vertically, right? Every time you measure the height of something, it's always vertical, perpendicular to the ground. So this is what you're looking for. Okay, questions on how I drew my picture? If you drew yours differently and it worked for you, do what works for you, okay? Tyler, question? Anybody have a question that didn't get it and are kind of confused? Okay, so from here, what trig function are we using? Tangent. It just depends. No, I mean, they may give you information like a lot of problems will talk about ramps or ladders leaning against a building. And if it's a ladder leaning against the building, then they're giving you the hypotenuse because it's leaning, right? Or if it's a ramp, you're driving up the ramp, that's going to be hypotenuse. So it may not be tangent every time. Okay, tangent of 52 is equal to x over 115. And again, the rule was if it's up high, we multiply. So x is going to equal 115 times the tangent of 52, approximately to the nearest foot, 147 feet. Questions? Okay, let's do the next one together, and then I'm going to let you try the last one on your own, okay? Okay. So it says an observer in a lighthouse is 69 feet above the water. So we've got water, we've got a lighthouse, and the observer up here, he is 69 feet above the water. He's just, yeah, he's hanging out in the air, floating, I don't know. Yes, very much so. That's okay. He sights two boats in the water directly in front of him. So from his line of sight, so let's make this go all the way up to his line of sight. He sights two boats in the water directly in front of him. So boat one, boat two. Everybody following kind of the big idea there? So the angle of depression, and this is where students get this wrong. Angles of depression do not go from the vertical. They go from the horizontal, which is not in my picture right now. So I'm going to have to draw it in. Here is a horizontal line. Okay? The angle of depression to the nearest boat. Which one's the nearest boat? Boat 1. So the angle of depression down to the nearest boat is 48 degrees. So which other angle in my picture is 48 degrees? Which B? B1. If I'm going up from the horizontal, so if my water was really horizontal here, then this is also 48 degrees. And again, I want to warn you, where I see students make a mistake is they put 48 right up here in this top angle with the vertical line. But it has to go from the horizontal, okay? So we know this is 48. We keep reading. It says the angle of depression to the other boat, so that means from the horizontal down to boat 2, is 22 degrees, right? So which other angle is 22? B2. Going up from the horizontal at B2 would be 22 degrees. Questions on my picture before I go any further? And we are assuming the lighthouse is making a right angle with the ground, right? Okay, so the question is, what's the distance between the two boats? Hold on, Tyler, go ahead. Say it again. Okay, very good. So what we're going to have to do, because remember, everything we've learned this chapter is about what kind of triangles? Right triangles. So we're going to have to find, I'm going to call this whole distance here y, and I'm going to call this distance from here to boat 1 z. And that means if I want to find x, I'm going to have to do what? Subtract y minus z, right? So x is going to equal y minus z. That means I need to find the whole thing y and the part z. So I'm looking at two different pictures. First, the longest one, y, with 69 being the leg. And what's the angle? 22, because it's the longest one all the way to here, right? And then I'm going to look at the shorter one. Still a right triangle with 69 for the leg, but this is now z, and what's my angle? 48. So we're going to do two separate problems, and then we're going to subtract before we round. So don't round until the very end, okay? So let's start with this first one. What trig function are we going to use? Tan, because we know the opposite, and we're looking for the adjacent. So we're going to do tangent of 22 equals 69 over y. And since y is down below, we switch, you know. So y is equal to 69 over the tangent of 22. Don't type that in and round. That's not your answer. So I'm going to put on the board over here that the first thing for y was 69 divided by the tangent of 22. That's my y. Is everybody with me? And we want to subtract from that z. So now let's find z. What trig function will we use for z? Tan again, because we know the opposite. We're looking for the adjacent. So tangent of 48 is equal to 69 over z. Since z is down below, again, we switch, you know. So z, switch, you know. So we have 69 over the tangent of 48. Is that making sense? Okay, but again, that's not my answer, so I don't want to round it yet. So I'm just going to type it in as 69 over the tangent of 48. And then I can do all of that on my calculator, or I can do the first part, hit enter, and then subtract and type in the second part. And that way the calculator is using the exact values, not rounded values. So try typing it in, and then round to the nearest foot and tell me what you get.
Yeah, no, I definitely typed something wrong.
I don't see a minus anywhere. I think that's where you are.
Oh, yeah.
We're subtracting. Okay, so I'm hearing that consistently we're getting approximately 109 feet. So if you don't get 109, let me know and I'll help you see where you're going wrong. $109 for the whole thing or $109 for this? Okay, so that was X. That was our little piece between the two boats, which is what it asked us for, right? Okay. Anybody not getting it typed in correctly, not getting 109, need me to help with the calculator or explain it better? Okay, so you may not want to do this, but you're going to do the last problem, and that's how you earn your homework. You're really going to earn your homework. But exactly. You're still going home with homework. But I'm not going to give you your slip until the bell rings or until you finish the next problem. Okay? So you're going to do the next problem. When you get the answer right, I'll give you your homework and you are free to work on it, okay? You have to get it right. And when you think you have it, let me know and I'll check it for you.